Hello and welcome back to the Jolly Franchers YouTube channel. We are a small group of people making a murder mystery RPG called The Kid Detective. And very soon, in fact right now, we are looking for beta testers. So please, if you want to be a beta tester, follow the link to our Discord down below and I will give you a Steam key and you can play the game, the demo as it stands right now, for free. So for this next video series, we will be learning how to make the secret of Monkey Island, inventory, point and click movement system with a character, how to avoid obstacles with nav mesh navigation, and did I already mention the inventory? And did I already mention we'll do that perspective trick that Monkey Island does? We can grow and shrink the character if it looks like they should move back and farther away in the scene. We're gonna do a whole bunch of stuff. So in this next series, we are going to learn how to make a game like The Secret of Monkey Island, a classic point and click adventure. And I actually have a demonstration for you right now. So over the course of this series, we are going to make something similar to this. This is a very important message at the beginning of the game. Hope you take note. We will make an inventory with items in it. We will be able to use the items. We will be able to click on things and go to places. Move around obstacles if we click somewhere with an obstacle in the middle of it, as you can see me elegantly moving around this desk. When we hover over things that are of note, our mouse cursor will change. We will talk to the things when we get there, but only when we get there. As you can see, I've arrived and now I'm talking to the plant. And we will then learn how to use the inventory items in Monkey Island type ways. So as you can see in the demonstration, we are going to be learning how to make a point and click character who animates walking from place to place. Once they get there, they will interact with the person or the object that you clicked on. You could even click on the edge of an area to have them walk to a new area. And we will be making a full-on inventory. I will show you how to make some of the utility that Monkey Island has. They have that old use, talk, push, pull, that kind of system. But for now, we will start with the very basics. In this video, we will learn how to move your character around. We will learn how to do that perspective trick that they have in Monkey Island. And we will learn how to keep your character confined into a space so that they can't walk through walls and stuff. So we're going to do that this episode. Okay, first things first is I am going to just drag in some random environment for us to look at. Okay, now that I have done all that for myself, and hopefully for you, to better be able to visualize what a point-and-click game could or couldn't look like, I am going to drag in. I'm going to make sure that she's just in the room. We'll put her over here. And make sure these numbers are somewhat clean. How so clean? And I'm just going to name this player. Okay, now we want to be able to point and click on places in this room and hopefully having her walk to the point instead of teleport instantly to the point that I click, because that's not how people walk around. It will actually be a piece of the final product. So I am going to name this script Target. You can name it whatever you like. Go to New Script, type in point and click controller, but I am going to name it Target. So if you're following through all of these videos, then that's why I have named it Target. We'll make a script called point and click controller later. So double click on this and open up your target script. So the first thing we are going to do is we want to save the position on the screen where we click. 2D games, the way we save the position of something is with a variable, which I'm going to make private for right now. Create a variable which is a vector2. And a vector2 is an XY coordinate. It will be the XY coordinate where we click our mouse. And I'm going to name it follow spot, because the player will follow this vector2 follow spot wherever we click on the screen. And the only other thing we are going to need here is the speed, a float named speed. We're making a float, which is any decimal point number, and we're naming it speed so that when we click on this follow spot position on screen, we can determine how quickly our player moves to that spot. We can adjust that. And I might go ahead and make this actually public so that, and I'm going to go ahead and save this to show you what making it public does. So when I made it public, the speed variable showed up here in the inspector so that we can adjust it if we see that the player is moving really slowly or not. Now, if we play the game right now, nothing will happen. We've made these variables, but we're not using them for anything. So now we need to go back in our script and use the variables. The first thing we want to do is we want to, when the game starts, or when we activate this script, we want to tell the follow spot to be where the player is, so that when we start the game, the player doesn't just randomly start wandering to wherever the follow spot is. And so I'm just going to put follow spot equals transform dot position p. So what this does is it will set the coordinate of the follow spot equal to the player's transform, as you can see here, and the position that it's at. So it's going to set it to 2 and 0.2, because that's where the player is when we will start the game. So we're just going to make sure the player starts standing still. And now for the actual magic. So we are going to, in our update method, we are going to make a new variable called mouse position. And we are going to set it equal to a handy dandy little function, camera.main.screen to world point. And you can go ahead and click on that. And as you can see, camera does not contain a definition for screen. Okay, so it wanted me to type in some parentheses before it showed me its helpful hints. This function here transforms a point from screen space into world space, where world space is defined as the coordinate system at the very top of your game's hierarchy. And that is referring to the transform that we looked at previously. I'll show you it again. The position of the transform. So as you can see, this function returns a vector3. A vector3 is a coordinate with a x coordinate, a y coordinate, and a z coordinate. We don't need the z coordinate because we're not making a 3D game today, but this just shows that you could make a point and click 3D game using this same function. And the coordinate that we want is input.mouse position. And we're going to put a semicolon, or what's this called? A semicolon here to make it know that this is all we want to do here. So we've made a new variable here called mouse position, which actually contains the coordinate of where our mouse is on the screen. This is what we have done thus far. And the way we are going to use this is if we click, if input.get mouse button down is 0, which I believe is left clicking, then so this new Vector2 wants me to type some parentheses, and it wants me to type the coordinates. So I'm going to set it equal to mouse position dot x, which is the x coordinate of our mouse position Vector3, and I'm going to give it the y position as well. So that's going to set our follow spot to there. Now, our follow spot isn't doing anything yet. All we've gotten is the XY coordinate where we want our player to go. So now we are going to set our actual position, our transform.position, which, by the way, when you type transform.position, it gets the transform position of the thing with the target script on it. You can just as easily type in this .transform.position, but that is extraneous, as it will immediately tell you. Name can be simplified. So the transform position of our player, we want to set it equal to follow spot. Now, if we just do this, our player will instantaneously transmit to the follow spot. So we don't want to do just this. We want to have our player move towards the follow spot at a speed that we choose. So the way we're going to do this is we're going to use a method called Vector2.Move towards, and it wants two different Vector2 positions where you're currently at, and where the player is currently at will always be their transform.position. It wants the target spot where we want the thing to move towards, which we have already made our follow spot. And this float that it wants at the end is, so this is where we obviously put in our speed variable, but we also want to use time.delta time. For the sake of this tutorial, let's look up why use time.delta time. Typically, time.delta time is used to move an object inside of update at a determined speed. In Unity, speed is typically considered to be represented in meters, as 1 Unity unit is 1 meter. If an object is moving along its z-axis at 1 times time.delta time, this would be 1 meter per second. Okay, so let's make sure you Control S or Command S on your script to save it, or you can go up to File, Save, I'm sure. And let's test out the horrible thing we've done today. We should make sure to set our speed equal to anything at all, or else we're not going to move before we do it. So I'm just going to go ahead and set this to 1. And let's see what happens. So our player is still, and now let's click somewhere. Oh boy. Oh boy. So my sprite was sliced incorrectly. I went and in my project, I made sure that when I clicked on the sprite editor, unfortunately the box of my character was like super wide. It was about 1.1 coordinates off on the X position. But now it works. See, when I click a place, the player moves towards it. Now, unfortunately, the player is not bound by anything, as you can see. They are moving through walls. It's incredible. This could be a superpower that you have. They're also not animating. They don't look like they're walking when they're walking. They do look like they're still when they're still. And in Monkey Island, there is a thing where when the player moves farther away from the camera, in quotation marks, it's really an illusion, but the player grows smaller as they walk backwards, and they grow larger in the foreground. So we can do all of those things. It may take multiple episodes, but we can do them. Okay, so let me tell you what I've done. As you can see, there's obviously something wrong, which we can fix immediately. But what I did was, in order to make it so that my player could not walk through walls, I added a box collider 2D to my player, and I edited it to, roughly take the shape of the legs. You could use a capsule collider to make the collision more smooth. And then I went ahead and made an empty game object, and I named it Boundary. And I added a polygon collider to it, and I edited the collider so that the area that I could walk was this trapezoid in the middle, and everything else was solid wall. And then I went ahead and added a rigid body 2D, which is sort of a physics simulation, so that when the colliders collide, they cannot move through one another as objects do. I set the gravity scale to 0 so the player doesn't fall straight down on the x-axis. And what I should have done is I should have frozen the Z rotation. So check freeze rotation Z. And almost immediately, our player will abide by the laws of physics. As you can see, the player is desperately trying to go through that wall, is trying to follow the follow spot. So that's not great. That's not ideal, this sort of jittering player. It is kind of funny, I will say. So we could add a little something to our player script that says, on collision, our player should stop following the follow spot, or the follow spot should change to be where our player is. So let's actually go and try that. I'm going to type in private on collision enter 2D, and I'm just going to click on that and press enter. It fills it in for me nicely. As you can see, it passes in the thing that you collide with. And I'm just going to say follow spot equals transform dot position. And hopefully this should work. I haven't tested this. And hopefully it should make it so that the follow spot is not outside the wall that you're colliding with, but it's back with you, and so you stop trying to walk through the wall. You know, like a person does. Oh, wow. You know, sometimes I'm just a genius and it works. Look, I'm not trying to mash through that wall. Well, it looks like it's getting a little chunky there. Looks like it's getting a little chunky. I'm going to switch this to on collision stay 2D instead of on collision enter, so that when we're up against a wall and we click outside the wall again, the player will not be able to move through the wall once they've reached the wall the first time. So as you can see with on collision stay 2D, our player tries to move through the wall briefly. You know, they can't really move because it switches the follow spot right back to the player's position. And as you can see, it's still pretty easy to get away from the wall. So this is a really basic way to, keep a player contained within the walkable area, have them not walk through boundaries very well. Okay, so at this juncture, learning how to move your player around without keeping them confined inside the room, they can still walk through walls. This is actually all you need to continue with the series. Next week, I will teach you how to navigate around objects and how to confine your player to a space. But if you want to learn a simple trick for that now, if it's good enough for you to not have objects in the middle of your room during your whole point and click, which lots of point and click adventures do, then you can continue on. I also come up with the adjust perspective method. And so if you want to learn those two things and watch me struggle through those, please continue forward. I think you'll learn something. So last thing we do in this video, let's make it so that when the player travels up on the Y position, they get smaller. And we're going to use the transform.scale in order to do that as a sort of Monkey Island perspective trick. So I'm going to make a new method, a private void called adjust perspective, which sounds very grand, I think. I'm going to go up here and I'm going to make a new public float called perspective scale, and this will allow us to more easily adjust how small and large we let the player get. And I'm going to say, okay, so I got something backwards. I think I should be multiplying instead of dividing, but I feel like kind of a genius because it's already kind of working. I'm just a little pink smear. I'm loving this. Okay, so I've spent a long time creating a method that adjusts your perspective when you go back into the scene. I started by creating two floats. One is called perspective scale and one is called scale ratio. You make sure that you put adjust perspective like this in your update. And I created a Vector2 called scale. And by default, I just set it equal to your scale, the scale of the game object itself. And then I say, now set the X value of the Vector2 scale equal to, basically I was trying to make this, you want to make this number so that when you change Y positions, when you go up and down on the screen, you want the change to be smaller rather than larger. I mean, it's going to depend on the scene that you're looking at, but in my scene, the perspective doesn't get that much smaller when my player goes towards the back of the room. So I didn't want the change to be drastic. So I subtracted the Y value, which in my case is a decimal point because I set my room, right on 0, 0. Like this point is 0, 0, 0 on the Y value. And towards the back of the room, it only gets to 0.6. So I wanted the change to be pretty small. You know, I didn't want my player to shrink too small. So this is just a handy tool. As you can see, I set my perspective scale and scale ratio to 1 and 1.5. This is just after fiddling around with it for about 30-40 minutes or so. I found the numbers that, you know, worked for me. Making games is hard. Figuring out how to make games is hard. So this is what I did. And then I transformed. I also, you know, set the Y value of scale to the same thing because I wanted to change the X and Y values of the player simultaneously, so it didn't get like, so if I only changed the X value, the player would just get skinnier as they move towards the back of the room, and if I only changed the Y value, they would just get shorter and they would look stout. So I changed both so that the player shrinks and grows in equal measure. I don't really like the effect that much, but in Monkey Island, it's great. So I wanted to give people the tools to do this. This is the simple version. Next time, we're going to go into what happens if you put a chair in the middle of the room. Obviously, if I come in here and I put a chair right in the middle of the room, so if I don't put a collider on the chair, obviously I pass underneath the chair all the time. When I'm in front of it, my whole self should be in front of it. When I'm behind it, my whole self should be in front of it, and I shouldn't be able to walk through solid matter. We've already established this. But if I put a polygon collider on this chair so that I can't walk through it, when I say click on this lamp or something and I want to go over and check this lamp, well, my character doesn't move around the chair. And that's pretty annoying. Like I have to click all these places to get my character around the chair. Whereas I could make it so the player automatically avoids obstacles in the scene and walks to wherever in the scene you click something. Okay, next time on the series of Monkey Island, TM, we will be learning how to navigate your player automatically around obstacles. And we are going to animate the player so that they look like they're walking when they're walking. Wow, that's most of it. And then the time after that, we'll do clickable objects and all the beautiful things you can do with clickable objects. And then the episode after that, we'll do the inventory, which may be 2 episodes because it might be really complicated. So make sure you subscribe and you keep commenting all the lovely comments you've been commenting. I really appreciate it, and I love to help out. So if you need help, please comment because I like to try to help you. Gosh. And please like the video as well and share with people, your friends, people on the internet. People like to make video games, and I think people would like it if they knew how easy it was, because it's easier than I think people think that it is, but it's also harder in some ways. So keep up the persistent spirit, you game developers out there, and stay jolly. Right, Bambo? Stay jolly, Bambo. Stay jolly.